Something unusual has occurred. Mere days after the 3I Atlas probe concluded its closest pass to our Sun, celestial observers have identified a phenomenon they did not anticipate: a sophisticated eruption of material originating from the object and extending in multiple directions. This is far from the straightforward tail one might expect from a conventional comet. It is something significantly more intricate, and the timing of this event is precisely what renders it so compelling. Allow me to pose a question. When was the last occasion you encountered a comet behaving in such a manner? Accelerating without any discernible cause, transitioning in hue from a deep red to a profound blue within a mere few days, shedding its tail, and then abruptly manifesting several emanating jets pointed in disparate directions. If you find yourself struggling to recall such an instance, it is because such an event has never been documented, at least not with any comet that has been subjected to our scrutiny. Here is what we currently understand. And believe me, this is where the situation becomes truly captivating. On the 24th day of October, the Meerkat radio telescope situated in South Africa registered an anomaly. This marked the initial radio signal detected from the 3I Atlas. It was not a deliberate transmission, but rather absorption signatures from hydroxyl radicals, O molecules, which were being expelled from the object. This detection transpired mere days subsequent to the celestial body reaching its perihelion, its closest proximity to the Sun. What is truly remarkable is not merely the successful detection itself, but what this signal divulges about the processes occurring on the surface of this entity. The hydroxyl radicals were identified at two precise radio frequencies, 1.665 and 1.667 GHz. The Doppler shift observed in these signals revealed a crucial detail. The object was indeed moving at the exact velocity anticipated. However, here lies the confounding aspect. Previous attempts to detect these very same signals in late September yielded no results. Absolute radio silence. Then, abruptly, as 3 Atlas executed its maneuver around the Sun, these molecules materialized. It is as if a switch was activated. Now, before we leap to any premature conclusions, permit me to elucidate what hydroxyl radicals are. They are fragments of water molecules that have been disassociated by intense solar radiation. Every comet expels them when it draws near to the Sun. This is a standard, expected occurrence. Yet, the temporal aspect of this event, the sudden appearance after weeks of inactivity, raises significant questions. Could the surface of 3 Atlas have been so frigid, so inert during its solar approach that it only commenced the release of gases at the very last possible moment? Or is there another explanation at play? Professor Abby Lowe, the Harvard astrophysicist who has been meticulously tracking this object since its inception, observed a particularly intriguing detail in his analysis. The thermal dispersion of the O absorption lines corresponded precisely with what one would expect from a surface temperature of approximately 230 Kelvin. This is indeed frigid, extremely cold. However, here is what truly captured his attention. The width of those absorption lines, referred to by astronomers as the full width at half maximum, was remarkably narrow, less than 1.5 kilometers per second. This suggests that the gases were not being expelled with any great force. Instead, they were subtly emanating, almost in a deliberate manner. But that is not the most perplexing aspect of this phenomenon. What transpired after perihelion is what has genuinely baffled astronomers. The Atacama Large Millimeter Array, ALMA, renowned as one of the most potent radio telescope networks on Earth, conducted observations of 3 Atlas and discovered something entirely unexpected. The object was deviating from its predicted trajectory by 4 arc seconds. While 4 arcseconds might not appear to be a substantial displacement in astronomical terms when tracking an object millions of kilometers away with highly sensitive instruments, this represents a significant departure. This is not a minor discrepancy in measurement, it is a tangible deviation. And this is where the situation becomes even more intriguing. The deviation was not erratic. It was consistent with an acceleration not caused by gravitational forces. Something exerted a subtle push on 3 Atlas, nudging it off its intended course. Comets routinely experience such occurrences. When ice vaporizes from the surface, it generates minute gas jets that function akin to minuscule thrusters, impelling the comet in various directions. This process is known as outgassing, and it is entirely natural. Except herein lies the problem. The magnitude of the acceleration observed was exceptionally pronounced for an object that exhibited relatively little observable outgassing activity. Consider this. If 3 Atlas were expelling sufficient gas to propel itself so far off its course, we should have witnessed a substantial coma, a vast cloud of gas and dust enveloping it. We should have observed a brightly illuminated active tail. Instead, what did we observe? A comparatively subdued object that in fact lost its tail shortly after perihelion. So, from whence did this acceleration originate? Lowe posited a theory that garnered considerable international attention. He did not dismiss the possibility, however remote, that the acceleration could be attributed to an artificial source, an internal propulsion system. Now, before you dismiss this notion as pure science fiction, consider his precise statement. He did not assert that extraterrestrial beings were involved. He stated that if no significant gas cloud is observed surrounding 3 Atlas in the coming weeks, then the non-gravitational acceleration might, and he emphatically stressed might, be interpreted as an indication of technological origin. This is the scientific method in action. One observes an anomaly. One seeks natural explanations. And if those explanations do not align with the gathered data, one contemplates alternative possibilities, even those that may be unsettling. But let us now address what transpired subsequently, for this is where the enigma deepens even further. Images captured by the Hubble Space Telescope and ground-based observatories have revealed something truly astonishing. Following perihelion, 3 Atlas began to display a complex arrangement of jets, not a singular tail trailing behind it as is typical of comets. Instead, multiple jets emerged from distinct points on its surface, pointing in various directions. It bore a greater resemblance to something actively managing its trajectory than to a comet. One particularly compelling image, obtained by the 2-meter twin telescope, depicted a sunward jet, a stream of material directed precisely towards the sun. This is highly unusual. Comet tails are repelled from the sun by the pressure of solar radiation, streaming behind the comet much like hair in a strong wind. However, a sunward jet suggests that material is being actively expelled from the side of the object facing away from the sun, with sufficient force to arc around and point towards the sun. Alternatively, and this is where conjecture enters, it could indicate directional venting from specific points on the surface. Why is this significant? Because if the outgassing were purely a passive process, driven solely by solar heating, one would expect it to be largely symmetrical, concentrated on the side facing the sun. But if jets are observed emanating from multiple locations, including the side not facing the sun, it implies a more complex scenario. Either the interior of 3 Atlas is remarkably warm, retaining heat even on the side not exposed to solar rays, or there exist specific vents, particular locations from which gas is being released, and then there is the inexplicable color alteration. We must address this phenomenon because it is profoundly peculiar. When 3 Atlas was first observed in July, it presented a reddish appearance. This is a common characteristic of celestial bodies. Cosmic dust and organic compounds tend to impart a reddish hue to objects. However, as it approached the sun, a transformation occurred. The object began to exhibit a blue coloration, a deep, intense blue. By the time it reached perihelion, it displayed a striking blue-green coloration, a sight rarely, if ever, witnessed in a comet by astronomers. While color changes in comets can be attributed to natural causes, such as the sublimation of different ices at varying temperatures, water ice, carbon monoxide ice, carbon dioxide ice, all vaporize at distinct points, and each scatters light differently. The shift from red to blue is counterintuitive. Typically, as dust is liberated from a comet, it scatters light in a manner that renders the comet redder, not bluer. So, what could account for this blue luminescence? One plausible explanation is that we are observing light scattered by exceedingly small particles, particles smaller than those typically found in comet dust. When particles are exceptionally minute, they scatter blue light more effectively than red light. This is the very same principle that accounts for the blue color of our sky. But if this is the case, from whence do these minuscule particles originate? And why did they only become apparent as the object neared the sun? Another possibility, and this is where speculation becomes more pronounced, is that we are witnessing emissions from specific gases. Cyanogen and diatomic carbon are both known to produce a blue-green glow when energized by sunlight. But again, the critical question remains: why now? Why did these gases suddenly appear in such quantities during and after perihelion? NASA issued a statement intended to allay public apprehension. Acting Administrator Sean Duffy addressed inquiries, including one from Kim Kardashian. Yes, that Kim Kardashian, reassuring everyone that 3 Atlas is merely the third interstellar comet to traverse our solar system. No extraterrestrial involvement, no impending threat, simply a comet behaving in a manner consistent with its nature. However, the reality is that not everyone is entirely convinced that the complete picture has been presented. Renowned physicist Dr. Michio Kaku publicly voiced his criticism of NASA, characterizing their approach as one of unnecessary secrecy surrounding 3I Atlas. In a strongly worded declaration, Kaku contended that the space agency has been withholding crucial imagery and data from the public, particularly the high-resolution images captured by the Mars Reconnaissance Orbiter on October 2nd and 3rd, when 3I Atlas passed within approximately 30 million kilometers of Mars. Kaku's critique did not end there. He highlighted specific data points that, in his view, raise serious questions regarding the fundamental nature of 3 Atlas. The object's estimated age, approximately 7 billion years, considerably predates the existence of our entire solar system. Its exceptionally high nickel content suggests that it is composed of materials far older and more resilient than anything originating from our local cosmic environment. And most provocatively, he noted that while an extraterrestrial origin for 3I Atlas remains a highly improbable scenario, esteemed scientists such as Harvard's Avi Loeb have not entirely ruled out such a possibility. Kaku's primary concern was not centered on the prospect of aliens. Rather, it was a matter of transparency. In Kaku's own words, unnecessary secrecy only fuels conspiracy theories. When the public is denied access to data, when images are delayed or withheld, individuals begin to question the motives. What is there to conceal? If 3I Atlas is indeed just a comet, why not release all the available data and definitively resolve the matter? And that fundamental question, that simple why, has now echoed through the corridors of Congress. Florida Congresswoman Anna Paulina Luna has formally requested that NASA release all observational data pertaining to 3I Atlas, specifically the images acquired by the Mars Reconnaissance Orbiter's HiRISE camera between October 2nd and 3rd. In her communication, Luna emphasized that this information holds significant importance for advancing our comprehension of interstellar visitors and their interactions with our solar system. However, her request extended beyond merely the Mars data. Luna also sought supplementary data from the Mars orbiter, the Perseverance rover, and other Mars missions that may have detected any unusual activity in proximity to Mars on or after October 3rd, when 3 Atlas made its closest approach to the red planet. The rationale behind focusing on Mars stems from the fact that this close pass presented a unique observational opportunity. Instruments situated on Mars possessed the capability to potentially observe 3 Atlas from a distinct vantage point, yielding data that Earth-based telescopes might have been unable to capture. If any anomalies were present regarding the object's trajectory, its surface activity, or its composition, the Mars missions would have been ideally positioned to detect them. The fact that this data has not been publicly disseminated weeks after the encounter has drawn considerable attention. Is NASA exercising caution, meticulously analyzing the data prior to its public release? Or is there something within those images that necessitates a more circumspect approach? We do not yet possess definitive answers. However, what we do have is an escalating list of anomalies, a growing array of behaviors that do not precisely align with the established characteristics of a typical comet, and an increasingly vocal chorus of individuals, from scientists and public figures to elected officials, demanding greater transparency. So, where does this leave us? What do we definitively know about 3I Atlas at this juncture? We know it is a real phenomenon. We know it originated from interstellar space. We know it is currently en route to its closest approach to Earth, scheduled for late December. We know it exhibited unusual behaviors during its perihelion passage, including a non-gravitational acceleration, a dramatic alteration in color, the disappearance of its original tail, and the development of intricate jet structures. We know it released hydroxyl radicals in a pattern that suggests a sudden activation rather than a gradual warming process. And we are aware that some of the world's foremost physicists and astronomers are perplexed by their observations. What remains unknown is the unfolding of future events. And that is precisely what makes this situation so profoundly captivating. Because in a matter of mere weeks, 3 Atlas will pass sufficiently close to Earth for amateur astronomers equipped with reasonably capable telescopes to observe it directly. There will be no necessity to rely solely on NASA, the ESA, or any other space agency. Thousands of independent observers will direct their instruments towards this object, and should anything unusual transpire, anything that deviates from the officially presented narrative, we will come to know of it. That is the inherent beauty of astronomy. It stands as one of the few scientific disciplines where amateurs can contribute meaningful observations, where transparency is not merely an option, but an inevitability. The cosmos belongs to all of us, but until that moment arrives, we are left with questions. Tantalizing, thought-provoking questions. Is 3 Atlas merely an exceptionally active comet from a distant star system? Or is there something more at play here? Something we have yet to contemplate? Something that challenges our fundamental understanding of what is conceivable? There is an element of timing that continues to perplex researchers, something that does not quite reconcile. Allow me to guide you through it, because once you perceive the pattern, it becomes impossible to ignore. 3I Atlas maintained a state of relative quiescence throughout its entire approach to the Sun. Months of observations revealed a standard, albeit somewhat dim, interstellar comet. Nothing particularly noteworthy. Then, within a span of merely a few days surrounding its perihelion, everything underwent a transformation. The radio signals materialized, the jets became active, the color shifted, and the trajectory deviated. It is almost as if the object possessed an awareness of precisely when to initiate its activity. Now, I anticipate your thoughts. Comets do indeed become more active as they approach the Sun. This is a fundamental principle of solar system physics. The closer one draws to a heat source, the more ice sublimes, and the greater the activity becomes. This process is gradual, predictable, and well understood. However, 3I Atlas did not adhere to this gradual progression. It was comparatively dormant, and then, quite suddenly, at its perihelion, it illuminated as if a switch had been flipped. Dr. Abbey Lowe highlighted a fascinating observation in his recent analysis. The Meerkat telescope attempted to detect those hydroxyl radical signals on two prior occasions before achieving success, once on September 20th and again on September 28th. Both attempts yielded no discernible results. No signal, no absorption lines, nothing. Then, on October 24th, 5 days before perihelion, there it was, clear, unmistakable, precisely where they were directing their instruments. So, what precipitated this change? Did the surface of 3 Atlas suddenly reach a sufficient temperature to release water molecules within those 5 days? It is a possibility. However, that would necessitate an immense temperature fluctuation within an exceedingly brief time frame. Or, and this is the question that is causing some researchers considerable unease, was there a delay mechanism in play? Something that prevented the surface from becoming active until a specific point in the object's trajectory. Before you form any definitive conclusions, let me be explicit. There are natural explanations for delayed outgassing. Some comets are enveloped by thick insulating crusts that impede the escape of gases until the internal pressure builds to a point where it forces its way through. It is analogous to a pressure cooker. Heat accumulates, pressure builds, and then, suddenly, with a burst, everything is released simultaneously. It is conceivable that this is what transpired here. However, here is what makes this particular scenario so intriguing. If 3 Atlas has been traversing interstellar space for potentially billions of years, enduring temperatures mere degrees above absolute zero, any surface ice should be pristine, unadulterated, devoid of the kind of dust and debris that would form an insulating crust. Objects at such frigid temperatures do not accumulate the materials that would obstruct outgassing. They are essentially clean ice spheres frozen in time, unless, of course, the surface is not composed of ice at all, or at least not primarily ice. This brings us to a point mentioned by Miyoaku that garnered significant attention: the unusually high nickel content. Now, I wish to be precise in my assertions because we do not possess direct spectroscopic analysis of 3I Atlas's surface composition. What we do have are preliminary assessments derived from the object's reflectivity, its coloration, and comparisons with known materials. However, if the nickel content is indeed higher than anticipated, that would be a significant revelation. Why? Because nickel is typically found within the cores of differentiated celestial bodies, such as planets and large asteroids, entities that were once sufficiently hot for heavier elements to migrate towards the center, while lighter materials floated to the surface. High concentrations of nickel are not commonly observed in comets, which are presumed to be primordial, undifferentiated aggregates of ice and rock that never attained the necessary heat to stratify into distinct layers. Therefore, if 3 Atlas exhibits a high nickel content, it suggests one of two possibilities. Either it is a fragment of a destroyed planet from another star system, a piece of core material that was propelled into interstellar space billions of years ago. Or, and this is where the implications become somewhat disconcerting for certain scientists, it is composed of something artificial, something manufactured. I understand how that sounds. I recognize it as a significant leap. However, let us approach this logically. If one were tasked with constructing a probe intended for an interstellar journey lasting potentially millions or billions of years, what materials would be employed? One would seek something exceptionally durable, something capable of withstanding cosmic radiation, micrometeorite impacts, and the extreme cold of interstellar space. Metals would be the material of choice. Nickel-iron alloys represent some of the most robust materials known. They do not degrade. They do not break down. They endure. Am I suggesting that 3 Atlas is a probe? No, I am suggesting that if we are to maintain scientific rigor, we must consider all hypotheses that are consistent with the observed data. And at present, the data is presenting us with something that does not perfectly align with the established model of a comet. Let us revisit the trajectory deviation, as there is more to this narrative. The Atacama Large Millimeter Array observed 3I Atlas and determined it to be 4 arc-seconds off its predicted position. Now, in his analysis, Lowe calculated the extent of outgassing that would be required to produce such a deviation. The figures are quite telling. To displace an object the size of 3 Atlas so significantly from its course would necessitate a substantial expulsion of gas. We are discussing tons of material being ejected at high velocity. However, here lies the critical issue. When such a considerable volume of gas is released, it invariably generates a visible coma, a large, luminous cloud of material surrounding the nucleus. This is an unavoidable consequence. The gas expands, carrying dust along with it, and scatters sunlight, rendering it readily observable from Earth. Every significant cometary outburst in recorded history has been accompanied by a dramatic intensification and expansion of the coma. It cannot be concealed. Therefore, where is the coma? Images obtained by the Hubble Space Telescope and various ground-based observatories depict a relatively compact object. Yes, there is some material in its vicinity. Yes, there are those jets we have discussed, but nothing on the scale that would be expected from an outgassing event, powerful enough to alter the trajectory by 4 arc-seconds. This is the very point that Lowe was alluding to when he introduced the possibility of a propulsion system. If the acceleration is not originating from observable outgassing, then from whence is it derived? There must be an underlying mechanism. Something is propelling this object. The fundamental laws of physics do not cease to apply simply because we are dealing with an interstellar visitor. One hypothesis that has been proposed involves subsurface venting. Instead of gases escaping uniformly from the sunlit surface, they might be channeled through internal fissures and expelled from specific locations. This has the potential to generate propulsion without forming a substantial, discernible gaseous envelope. It represents a clever resolution, and it is indeed achievable, but it would necessitate a highly specialized internal configuration, a system of conduits or orifices precisely aligned to produce detectable acceleration. What is the probability of such a characteristic in an object of natural origin? That, precisely, is the prevailing inquiry. Now, let us turn our attention to an event that transpired recently which has garnered even less consideration than it warrants. The emergence of what Mr. Lowe characterized as an intricate jet-like formation. This is not your commonplace cometary narrative. This is something altogether distinct. Imagery acquired from numerous astronomical observatories has revealed 3I Atlas, exhibiting jets originating from diverse points across its surface. Some are directed away from the sun, which is the conventional behavior, but others are oriented in divergent directions, laterally, and even toward the sun. This configuration creates an appearance that some have described as nearly geometric, ordered, rather than haphazard. One of the most finely detailed images was captured by the 2-meter twin telescope, which documented what appears to be a sunward jet. This is a jet pointing towards the sun, which, as I previously stated, is unconventional. Cometary tails are propelled away from the sun by the solar wind and the pressure of solar radiation. They stream behind the comet, akin to banners in a gust of wind, invariably away from the sun, always. However, a jet directed towards the sun suggests active expulsion of material from the object's unilluminated side with sufficient force to counteract solar radiation pressure, or it implies the ejection of matter in a trajectory entirely unrelated to passive solar heating. In either scenario, it signifies processes that elude our complete comprehension. What is particularly captivating is that the jet structure manifested subsequent to perihelion rather than during the approach. Most comets exhibit peak activity during their approach to the sun and at perihelion. As they recede, they cool, their activity diminishes, and they gradually revert to a dormant state. Yet 3I Atlas seems to have augmented its activity following its closest stellar proximity. This is the inverse of what we typically observe, unless, of course, perihelion was not merely a gravitational interaction, unless it served as a catalyst. I wish to pause at this juncture to address a matter of significance. Throughout this entire discourse, I have been positing hypothetical scenarios and posing questions. This is intentional, as we are currently at a stage in this narrative where our inquiries outnumber our resolutions, and this is perfectly acceptable. Indeed, this is the very manner in which scientific inquiry is intended to function. The challenge arises when we cease to pose questions, when we prematurely settle on an explanation because it is comfortable or familiar, when we disregard anomalies because they do not conform to our existing theoretical frameworks. That is not science, that is adherence to doctrine. And at present, there exists a divergence within the scientific community between those who advocate for a meticulous examination of every facet of 3I Atlas with an unprejudiced outlook, and those who have already concluded that it is simply a comet, and any suggestion to the contrary is mere sensationalism. This divergence reached a critical point in a recent interview between Avi Lowe and a British journalist on LBC. The interviewer persistently questioned Mr. Lowe regarding the prudence of not unequivocally dismissing the potential for an artificial origin. The underlying assumption was that a responsible scientist would assert, "It is unequivocally a comet. There is nothing to be concerned about. Proceed as usual." However, Mr. Lowe countered this by arguing that the truly irresponsible course of action would be to arrive at conclusions before all the data has been amassed, to presume knowledge of an object's nature before its thorough investigation, and to permit our preconceived notions about expected findings to obfuscate our analysis of what we are actually observing. And, I must confess, he is entirely correct. Consider this analogy. Imagine if astronomers in the 19th century had detected radio waves originating from space. They would have possessed no conceptual framework for understanding them, no awareness of pulsars, quasars, or any natural source of radio emissions. Had they adhered rigidly to established dogma, they might have dismissed these observations as instrumental malfunctions or external interference. They might have declined to publish the data because it contradicted their understanding of the cosmos. However, the truly exceptional scientists of that era would have meticulously documented the observations, disseminated the data, and candidly admitted their inability to identify the source. They would have deferred to future generations of scientists equipped with superior instruments and enhanced comprehension to resolve the enigma. This is precisely the predicament we face presently with 3I Atlas. We are witnessing phenomena that do not perfectly align with our established models. We encounter anomalies, and we are confronted with unanswered questions. The appropriate response is not to contort all evidence to fit the cometary model and consider the matter closed. The appropriate response is to persist in observation, to continue analysis, and to remain receptive to wherever the data may lead us, even if that direction proves to be unexpected. There is another element that has been perplexing researchers: the estimated age of 7 billion years. Now, from where does this figure originate? It is not as though we can perform carbon dating on an object in space. This estimation is derived from the object's trajectory and velocity projected backward through the galaxy. When one calculates the origin of 3I Atlas based on its current velocity and direction, one arrives at a region of space where stars began forming approximately 7 billion years ago, significantly older than our Sun, which is a mere 4.6 billion years old. This suggests that 3I Atlas originated from an ancient stellar system, one that coalesced when the universe was half its present age. Why is this significant? Because objects of such antiquity have had an extensive period to be shaped by their surroundings, a considerable duration for modifications to occur, and ample time to potentially encounter phenomena beyond our current imagination. If 3I Atlas is indeed 7 billion years old, it has traversed interstellar space for a duration exceeding the existence of complex life on Earth. This is a journey we can scarcely fathom. What transpires with an object over such a vast timescale? Does it remain unaltered, unaffected by the passage of eons? Or does it undergo transformation? Does it accumulate matter? Does it interact with interstellar clouds? Does it pass through regions of space of which we have no knowledge? We do not possess this information. We have never tracked an entity over such an extended temporal span. Every comet that we have meticulously studied has been an inhabitant of our solar system, billions of years younger, with a documented history. 3I Atlas is exceptional. It is a visitor from deep time, and that alone renders it deserving of extraordinary scrutiny. However, there is an additional factor, something that transpired recently and has not received nearly sufficient attention, involving a signal that some researchers are describing as uncannily familiar. The detection of hydroxyl radical absorption by MeerKAT occurred at frequencies of 1.665 and 1.667 gigahertz. Now, these frequencies hold significance in astronomy, as they fall within the general vicinity of the renowned WOW signal, detected in 1977. The WOW signal was received at 1.42 gigahertz. Not precisely the same, but sufficiently close to warrant raised eyebrows. But here is what is truly compelling. When Avi Low analyzed the arrival vector of 3I Atlas, he determined that it originated from a celestial region situated within 9 degrees of the WOW signal's source. 9 degrees. That is less than 20 times the apparent diameter of the full moon in the sky. Is this a mere coincidence? Most likely. Space is vast, and 9 degrees represents a rather considerable angular separation in astronomical terms. However, it is the sort of coincidence that prompts contemplation, that encourages reflection, particularly when juxtaposed with all the other elements we have been discussing. The WOW signal remains one of the most profound enigmas in the pursuit of extraterrestrial intelligence. It was a powerful, narrow-band radio transmission that lasted for 72 seconds and has never been detected again. It was so anomalous that the astronomer who first observed it on the printout penned the word WOW in the margin, and the designation persisted. For decades, scientists have endeavored to ascertain a natural explanation for the WOW signal. Some have posited interference from a passing satellite, although the signal's characteristics do not align with such a hypothesis. Others have proposed a comet releasing hydrogen clouds, though subsequent observations of the implicated comets yielded no corroborating evidence. The signal remains unexplained. And now we have 3I Atlas, originating from nearly the same sector of space, exhibiting peculiar behaviors and emitting detectable radio signatures. Am I asserting a connection? No. But am I suggesting that it is sufficiently intriguing to warrant investigation? Absolutely. This is precisely the type of data that should be made accessible to the public. This is precisely why transparency is paramount, because when multiple anomalies appear to converge towards a single direction, it necessitates the involvement of the broader scientific community. It requires independent verification. It demands diverse perspectives and specialized expertise to scrutinize the same data. Which brings us back to the current controversy: the withheld imagery, the delayed dissemination of data, and the escalating frustration among researchers and the public. Congresswoman Anna Paulina Luna's correspondence to NASA was not merely a courteous request. It was a formal demand for specific data that, according to her office, should have been publicly available weeks ago. The High-Resolution Imaging Science Experiment, HiRISE, camera aboard the Mars Reconnaissance Orbiter captured images of 3I Atlas on October 2nd and 3rd. These were high-resolution images, the kind that could potentially reveal surface topography, jet activity, and perhaps even structural characteristics. Where are these images? NASA's official stance is that all data undergoes standard review procedures prior to public release, including quality assessments, calibration, and analysis. This is customary practice and typically requires time. However, here is the crucial point. When the Mars Reconnaissance Orbiter documented images of other comets, asteroids, and objects of interest, those images were released within days, and in some instances, within hours. The standard review process did not extend for weeks. So, why is 3I Atlas an exception? Michio Kaku did not hesitate to express his opinion on this matter. He unequivocally stated that there is no valid justification for the delay. In his estimation, and he is not alone in this view, the images should be declassified without delay. This is not classified military intelligence. It is not sensitive national security information. It is an astronomical observation of an object, natural or potentially natural, traversing our solar system. The default position should be openness, not concealment. His concern, and it is a well-founded one, is that delays inevitably foster suspicion. When the public perceives that data is being withheld, they begin to question the reasons. And in the absence of official explanations, they construct their own narratives. Some of these narratives are measured and rational, while others are outlandish and conspiratorial. However, all of them originate from the same fundamental cause: a deficit of information. If NASA possesses the images and they depict a mundane, ordinary comet engaged in typical cometary activities, then they should be released. The issue would be resolved, speculation would cease, and everyone could move forward. But if the images reveal something unusual, something that necessitates careful analysis and deliberation before public disclosure, then we are in different territory. In that case, the delay becomes understandable, but it also confirms that there is indeed something warranting a cautious approach. In either scenario, the silence is becoming unsustainable. Kaku also highlighted an aspect that has received minimal attention in the mainstream media coverage. The Perseverance rover and other Mars missions were active during 3I Atlas's closest approach to Mars. These missions are equipped with instruments, cameras, and spectrometers. If any unusual activity occurred, if any detectable phenomenon was registered, those missions would have recorded it. Congresswoman Luna's letter specifically requested supplementary data from Perseverance and other Mars missions that may have been in proximity to or operating after October 3rd. The wording is noteworthy. Unusual activity, not merely observations of the comet, but unusual activity. What precisely does this activity entail? We do not know, as the data has not been released. However, the fact that a member of Congress felt it imperative to formally request it suggests that inquiries are being made behind closed doors, inquiries to which the public is not yet privy. Let me be perfectly clear on one point. I am not suggesting the existence of a widespread conspiracy to conceal evidence of extraterrestrial spacecraft. That is not the subject at hand. The core issue here is the fundamental principle of scientific transparency. When public institutions, funded by taxpayer resources, conduct observations of celestial bodies within our solar system, that data belongs to everyone. It should be disseminated, subjected to scrutiny by independent researchers, and openly debated, analyzed, and discussed. This is the mechanism by which science progresses, not through secrecy, delayed releases, and carefully managed public relations, but through open collaboration and peer review. And at present, this is precisely what we are not experiencing. Here is a recent development that adds another dimension to this narrative. Reports have emerged indicating that 3I Atlas has been experiencing what some are terming velocity shifts. This refers not to a singular acceleration detected near perihelion, but to ongoing alterations in speed that do not precisely conform to gravitational models. Now, before we proceed further, allow me to clarify what this signifies. When one tracks an object in space, it is possible to predict its future position based on its current velocity and the gravitational forces acting upon it. The Sun exerts a pull. The planets exert their influence, albeit much less significantly. One aggregates all these forces, performs the calculations, and derives a projected trajectory. For 3I Atlas, these projections have necessitated multiple revisions. Each time astronomers acquire new observational data, they discover that the object is not precisely where the model indicated it should be. These are minor deviations, yes, but they are consistent, and the adjustments required to align with the observations suggest that some factor beyond simple gravity is influencing its velocity. Outgassing is the most obvious candidate. As I have mentioned, when comets release gas, it can subtly alter their course. However, here is the intriguing aspect. The velocity changes do not appear to correlate precisely with visible outgassing activity. There have been periods when the object appeared relatively quiescent, yet its trajectory still required modification. Conversely, there have been intervals of apparent activity during which the trajectory remained closer to the predictions. It is almost as if the outgassing, if indeed that is the cause, occurs in discrete bursts, timed bursts, rather than the continuous, gradually evolving activity one would anticipate from passive solar heating. Avi Lowe has been closely monitoring this phenomenon, and in one of his recent communications, he proposed a concept that garnered international attention. He stated that if 3I Atlas continues to exhibit trajectory modifications without corresponding visual evidence of substantial gas release, we might need to entertain the possibility that we are observing controlled adjustments. Controlled is the operative word that captured public interest, because controlled implies intention, implies purpose, implies an entity making decisions about its course. Now, Mr. Lowe was careful to frame this as a hypothesis to be tested, not a definitive conclusion. He outlined the specific observations that would be necessary to either confirm or refute this proposition. namely, precise monitoring of the object's velocity over the ensuing weeks, coupled with simultaneous observation of any gas or dust emissions. If the velocity changes without visible emissions, that is significant. If emissions occur without discernible velocity changes, that is also significant. Either outcome would provide crucial insights into the prevailing processes. However, to conduct such an analysis, to definitively ascertain what is occurring, we require data. We need those images from Mars. We need spectroscopic observations across a range of wavelengths. We require radio telescope monitoring. We need every scrap of information we can gather, and some of that data is presently stored on NASA's servers, unreleased. Let us consider what is likely to transpire next, as this is where the situation becomes genuinely captivating. 3I Atlas is currently on a trajectory that will bring it to its closest proximity to Earth on December 19th. That is approximately 5 weeks from now. At its closest point, it will pass within approximately 93 million kilometers of our planet, which is roughly 60% of the Earth-Sun distance. While not exceptionally close by astronomical standards, it is sufficiently near. Sufficiently near for what? Sufficiently near for detailed observation by both professional and amateur astronomers globally. Sufficiently near for spectroscopic analysis that could elucidate its composition. Sufficiently near for radar observations that might reveal surface features. Sufficiently near to potentially resolve some of these questions definitively. However, here is the critical point. That December 19th flyby is not merely an opportunity for passive observation. It is a test of everything we believe we understand about this object. If 3I Atlas is simply a comet, its behavior during its approach to Earth should be predictable. It might become slightly brighter due to increased solar heating as it navigates the inner solar system. It might develop more discernible tail activity, but fundamentally, it should behave as comets typically do, passively, predictably, adhering strictly to the laws of physics. However, if 3I Atlas is something else, if there is any validity to the more speculative hypotheses being discussed, then the Earth flyby could potentially trigger a change in trajectory, a modification in its activity, something that would reveal its true nature. Am I suggesting that we should anticipate alien spacecraft decloaking and initiating contact? No, that would be absurd. But am I suggesting that we should meticulously observe any anomalies during that flyby? Absolutely. Because anomalies are the very means by which we learn. Anomalies are how we uncover new physics, new chemistry, new phenomena that we were previously unaware of. And 3I Atlas has already presented us with a considerable number of anomalies. There is another dimension to this situation that has not been extensively discussed, but it merits consideration: the psychological and cultural impact. For the first time in human history, we are witnessing an object originating from another star system traverse our cosmic vicinity in real time. This is not akin to Oumuamua, which we detected as it was departing. Rather, this is an object we are tracking from its approach, through perihelion, and towards its departure. And its behavior is sufficiently peculiar that serious scientists are publicly discussing the possibility, however remote, that it may not be entirely natural. Consider the implications of this. Reflect on how this alters the discourse. For decades, the search for extraterrestrial intelligence has been largely theoretical. We have transmitted radio signals into the cosmos, listened for replies that never arrived, and searched for technosignatures in distant star systems. It has been an exercise in patience, statistics, and hope. But 3I Atlas has brought that search directly into our neighborhood. Suddenly, it is no longer about signals emanating from hundreds of light years away. It is about something in our immediate vicinity, something present now, passing through our solar system. something we can observe directly, something we might even be able to interact with. Even if it ultimately proves to be entirely natural, even if every anomaly is attributable to a mundane explanation, the very fact that we are engaging in this conversation is significant. It signifies that we are giving serious consideration to the possibility of contact. It means we are posing the pertinent questions. It implies that we are intellectually and scientifically prepared to handle whatever answers we may uncover, and that, in itself, constitutes progress. Genuine progress. However, let us bring this discussion back to Earth, quite literally. What can you, as an individual interested in this unfolding story, actually do? What role can the public play in unraveling this enigma? Firstly, if you have access to a telescope, direct it towards 3i Atlas. Observations from amateur astronomers have significantly contributed to our understanding of comets throughout the years. You do not require a research-grade instrument. A reasonably capable backyard telescope equipped with a camera can capture valuable data, particularly if you maintain consistency and meticulously document your findings. Secondly, maintain a stance of skepticism, but remain open-minded. There is a considerable amount of extraneous information surrounding this narrative, an abundance of sensationalized headlines and unbridled speculation. However, there is also legitimate scientific inquiry in progress. Cultivate the ability to differentiate between the two. Seek out primary materials. Engage directly with the original research articles and detailed observation logs rather than relying solely on condensed summaries. Thirdly, champion openness and accountability, not through aggression or confrontation, but with unwavering persistence. Communicate with your elected officials. Reach out to NASA. Correspond with the scientific publications. Inform them that the public is actively observing and anticipates being kept fully apprised. Transparency is not merely a matter of sound ethics, it is fundamental to robust scientific practice. And fourthly, acknowledge that ambiguity is an acceptable part of the process. We are not compelled to possess all the answers instantaneously. We need not rush to premature conclusions before the relevant data has been fully gathered. It is entirely appropriate to state, we currently lack definitive knowledge, but active research is underway. Indeed, such a declaration is frequently the most candid and scientifically sound response. Here is an element I find particularly captivating within this entire unfolding scenario: the correspondence that Avi Loeb has been receiving. He generously shared several of these messages in a recent blog post, and they offer profound insights, not about 3i Atlas itself, but about the impact this narrative is having on individuals globally. An educator from Italy expressed gratitude for his dedication and candor. A digital content producer from South Africa proposed assisting in amplifying public awareness. A visual artist from Kenya conveyed thanks for illuminating humankind. Individuals from Mexico, the United Kingdom, and Florida all have reached out with a common sentiment. Thank you for posing critical questions. Thank you for refraining from accepting facile explanations. Thank you for treating this subject with the seriousness it warrants. This collective response conveys a significant message. People are eager for this caliber of scientific inquiry, not simplified for mass consumption, nor sensationalized, but characterized by rigor, honesty, and an embrace of the unknown. They desire to participate in the discourse. They wish to comprehend the phenomena occurring within our cosmos, particularly when those events are perplexing and unusual. And this is precisely the kind of engagement that is vital, because the inquiries prompted by 3i Atlas extend beyond mere scientific curiosity. They delve into philosophical territories. They question our cosmic positioning. They probe what we should anticipate encountering as our exploration ventures beyond our terrestrial origins. They examine how we ought to react should we ever come into contact with something truly extraordinary. These are dialogues that should be undertaken by society as a whole, not exclusively within the scientific community, because the resolutions, whatever they may ultimately be, will affect every one of us. Before we proceed, there is one additional matter I wish to address. The criticism some scientists have encountered for merely considering the potential for Three-Eye Atlas to be artificial. The charge that they are being irresponsible, sensationalist, or seeking undue attention. This criticism fundamentally misunderstands the essence of scientific endeavor. Science is not about safeguarding established doctrines or maintaining comfortable assumptions. Science is about pursuing evidence wherever it may lead, even if that path diverges into unexpected or disquieting territory. When Oumuamua was detected and displayed its peculiar elongated form and acceleration, Avi Loeb posited it might possess an artificial origin. He faced severe condemnation for this suggestion. His peers dismissed him. The media ridiculed him. Yet, consider this. He meticulously articulated his reasoning, proposed specific investigative methods, and invited others to refute his hypothesis through superior data and analysis. This is the very mechanism by which science is intended to function. Hypotheses are put forth, even those that are uncomfortable. They are then subjected to testing. Data is collected, and the evidence is permitted to dictate the conclusion. With Three-Eye Atlas, we are observing a similar pattern emerge. Anomalous observations, proposed explanations ranging from the commonplace to the highly speculative, and resistance from those who have already predetermined the answer without examining all the available evidence. However, here is the crucial point. The universe is indifferent to our preconceptions. It does not alter its behavior to conform to our expectations. If Three-Eye Atlas is exhibiting unusual characteristics, it is doing so irrespective of our comfort in acknowledging it. Our responsibility as observers, thinkers, and inherently curious beings is to meticulously document our observations and interpret them with integrity, not to force them into frameworks they do not adequately fit, not to disregard anomalies simply because they are inconvenient, but to engage with reality as it presents itself, rather than as we wish it to be. And currently, reality is offering us something genuinely perplexing, something for which a straightforward, simple explanation is not yet available. Something that necessitates further investigation, additional data, and more thorough analysis before we can confidently ascertain its nature. Therefore, let us diligently acquire that data. Let us conduct that analysis, and let us discover where it leads us. There is another development occurring that warrants attention, something that has been unfolding quietly while the focus has been on the profound questions surrounding the nature of Three-Eye Atlas. And this involves the events transpiring presently in November as the object continues its trajectory through our solar system. The intricate structure of jets we discussed earlier remains active. In fact, observations from the preceding week indicate its evolution. The jets are not static. They are in flux, shifting, almost as if being regulated. Certain jets have diminished in intensity. Others have intensified. New ones have materialized in areas that were previously inactive. This is an unusual occurrence. When comets develop jets, they typically sustain them for prolonged durations, provided the heat source, the sun, remains relatively constant. One does not commonly witness rapid on-off cycling of jet activity. Jets do not typically appear and vanish on timescales of days or even hours, yet this is precisely what multiple observers are reporting with Three-Eye Atlas. What could be the underlying cause? One plausible explanation is that the object is rotating, bringing different surface regions into and out of direct sunlight. As a new area is exposed to the sun, it warms and begins to release gases, creating a jet. As it rotates away, it cools, and the jet ceases. This is a conceivable scenario, but it would necessitate a very specific rotational velocity and a highly uneven surface composition. Another intriguing possibility is that the jets are not purely passive phenomena. It suggests that an internal mechanism is governing the timing and location of gas release. This could be a natural process, perhaps involving pressure buildup and subsequent expulsion through specific conduits, or it could involve something else entirely, something responsive to external influences in ways we do not yet fully grasp. Loeb has been meticulously tracking these jet variations and has noted something peculiar. The changes do not appear entirely arbitrary. A pattern exists, though it is not immediately apparent. Some jets activate when the object assumes particular orientations relative to the Sun. Others seem to react to its position in relation to Earth. It is subtle, but undeniably present. Now, am I asserting that the object possesses awareness of Earth and is reacting to our observations? That would be an extraordinary claim. But am I suggesting that there might be correlations between the object's activity and its geometric relationship with significant gravitational bodies? That is an avenue worthy of investigation, because if such correlations exist, they would offer insights into the driving forces behind its activity. Here is an event that occurred just 3 days ago, which, while not making major headlines, arguably should have. The Juno spacecraft, currently orbiting Jupiter, was repurposed to attempt observations of 3I Atlas. The effort yielded only partial success due to the immense distance and viewing angle. However, Juno's instruments did detect a faint radio signal, distinct from the hydroxyl absorption noted by Meerkat, but within a similar frequency range. The signal was transient, lasting only a few minutes, and has not been detected again since. It is possible it was instrument noise. It could have been interference from Jupiter's potent magnetic field. Alternatively, it might represent a genuine detection. We will not know for certain until the data undergoes comprehensive analysis and, ideally, until other observatories corroborate or refute this finding. However, the mere fact that Juno was directed towards 3I Atlas conveys a significant message. It indicates that NASA considers the object sufficiently intriguing to reallocate spacecraft resources and dedicate valuable observation time to an entity officially classified as merely a comet. Such actions are not undertaken for ordinary comets. They are reserved for situations where pressing questions demand answers. Looking ahead to the December flyby, there is another factor to consider: the viewing geometry. As 3I Atlas approaches Earth, we will be observing it from a fundamentally different perspective than we have thus far. This shift in vantage point may reveal features that have remained obscured. It could expose facets of the object that have not been illuminated or visible from our current position. And this is where the situation becomes particularly compelling. If 3I Atlas is a naturally occurring object with an irregular shape, the manner in which light reflects off its surface should change predictably as our viewing angle alters. We should observe fluctuations in brightness that correspond to its rotation and form. Astronomers refer to this phenomenon as a light curve, and it serves as one of our most effective instruments for comprehending the physical characteristics of distant celestial bodies. However, if 3I Atlas is not rotating, or if its rotation is unconventional, or if its surface reflectivity is somehow actively controlled rather than passively determined, its light curve will deviate from expectations. It may not adhere to the predicted pattern, and such a divergence would be highly significant. Several research groups have already announced their intention to conduct intensive light curve monitoring during the December flyby. They will be vigilant for any departures from anticipated behaviors, any anomalies, any indications that this object may be more than it initially appears. Furthermore, there is the question of what transpires after the flyby. Following December the 19th, 3i Atlas will commence its extensive outward journey from our solar system. It will traverse beyond the orbital path of Mars, then Jupiter, and eventually recede into the outer solar system, ultimately re-entering interstellar space. The entire duration of its visit, from initial detection to its departure, will have spanned less than a year. However, before it departs, one final opportunity for close observation will arise. In March of 2026, 3i Atlas will pass within 53 million kilometers of Jupiter. This proximity is considerably closer than its approach to Earth, and Jupiter's immense gravitational influence could potentially trigger an event. If any volatile materials remain on its surface, Jupiter's gravitational pull could subject the object to significant stress, potentially fracturing surface layers and releasing further gases. The Juno spacecraft, which I mentioned earlier, will be strategically positioned to observe this encounter. Its sophisticated instruments will be monitoring for any alterations in the object's trajectory, any indications of outgassing, and any radio emissions. This could represent our final, optimal opportunity to gather detailed data on 3i Atlas before it vanishes into the cosmic void. Now, allow me to address a matter that has been subtly present throughout these discussions. The possibility, however remote but not entirely absent, that 3i Atlas represents some form of probe or artifact. If this were the case, and I must emphasize that there is currently no definitive evidence to support this assertion, but hypothetically, if it were true, what would we anticipate observing? Firstly, we would expect trajectory adjustments that are not correlated with visible gas expulsion. This aligns with what we are observing. Secondly, we would anticipate some form of energy emission, either radio signals or other electromagnetic radiation that deviates from the characteristics of natural cometary activity. This is a potential match. While the hydroxyl absorption is a natural phenomenon, the faint signal detected by Juno, if genuine, does not currently possess an obvious natural explanation. Thirdly, we would expect the object to exhibit some response to its environment, demonstrating behaviors that suggest an active interaction with its surroundings in a purposeful manner. This is where speculation becomes more pronounced, but the evolving jet patterns, the color variations, and the timing of various activities could all conceivably fall into this category. Fourthly, we would anticipate it possessing an unusual composition or structure inconsistent with known natural objects. The elevated nickel content, if confirmed, would qualify. The apparent absence of a substantial coma, despite measurable acceleration, would also qualify. Its age and point of origin might also be noteworthy. However, here lies the critical point. Each of these observations also possesses potential explanations rooted in natural phenomena. Trajectory adjustments could be attributed to outgassing that we are not adequately detecting. Radio signals might be instrumental artifacts. Color changes could be the result of exotic yet natural chemical processes. A high nickel concentration could indicate it originated from a fragment of a destroyed exoplanet. We possess suggestive data, we have identified anomalies, but we lack definitive proof, not at this juncture, perhaps not ever, and that is perfectly acceptable. That is the essence of scientific inquiry. We operate with probabilities and evidence, not with absolute certainties or unwavering beliefs. What we must diligently avoid is leaping to conclusions in either extreme. We should not definitively declare it artificial based on the current dataset, nor should we unequivocally assert its natural origin and dismiss all anomalies as measurement errors or expected variations. The truth, irrespective of its nature, will emerge from meticulous, systematic observation and analysis. Here is what I consider to be the most significant aspect of the 3i Atlas narrative. Regardless of the object's ultimate classification, it has fundamentally altered the discourse. It has imbued the possibility of detecting artificial objects within our solar system with a tangible and immediate sense of reality. It has demonstrated that we possess the necessary capabilities and expertise to investigate such entities should they exist, and it has proven that the scientific community, despite some initial reluctance, is willing to entertain extraordinary hypotheses when the data warrants such consideration. This represents progress, genuine, meaningful progress in our approach to the fundamental question of whether we are alone in the universe. Consider the advancements we have made. Merely a few decades ago, the concept of studying interstellar objects was purely theoretical. We understood they must exist, entities ejected from distant star systems, traversing the galaxy. However, we lacked the means to detect them. Then, Oumuamua appeared in 2017, suddenly transforming interstellar visitors from theoretical constructs into tangible possibilities. Subsequently, 2I Boris in 2019 confirmed that such objects regularly traverse our cosmic neighborhood. And now, 3I Atlas, the third such visitor, each one distinct, each one imparting new knowledge, each one prompting questions we had not previously contemplated. What will the fourth visitor resemble? The 10th? The 100th? As our detection capabilities continue to advance, we will identify more of these objects, a significantly larger number, and each one will present an opportunity to learn about other star systems, diverse planetary formations, and alternative origins of life. Some will undoubtedly be unremarkable icy bodies. Others will be intriguing rocky fragments with unusual compositions, and perhaps, just perhaps, one of them will be something else entirely, something that compels us to reevaluate our position within the cosmos. Are we adequately prepared for such a revelation? Scientifically and culturally, are we ready to confront the genuine detection of extraterrestrial technology? Based on the response to 3I Atlas, I would venture to say that we are making strides in that direction. The conversation is underway. Protocols are being formulated. The intellectual framework is being established. When, not if, but when we eventually encounter something undeniably artificial, we will not be starting from a blank slate. We will possess accumulated experience. We will have established precedents. We will have learned from objects like 3I Atlas how to approach the unknown with both rigor and an open mind. This may well be the most enduring legacy of this object, irrespective of its ultimate identity. It is teaching us how to formulate pertinent questions, how to navigate uncertainty, and how to maintain scientific discipline while remaining receptive to extraordinary possibilities. Allow me to conclude with this thought. In the coming weeks, as 3I Atlas approaches Earth, remain attentive, monitor the news updates, seek out information from observatories. If you have access to a telescope, endeavor to observe it yourself. Become a participant in this historical moment, because whether 3I Atlas is a comet, a fragment of a planet, or something beyond our current comprehension, it is exceptional. It is a visitor from beyond our solar system, carrying with it information about places and processes that we may never directly witness. It is a cosmic offering delivered to our doorstep at a time when we are finally equipped to study it effectively. Do not let this moment pass unnoticed. Do not allow critical questions to remain unasked. And do not permit anyone to persuade you that curiosity about the unknown is foolish or unscientific. Curiosity is the very essence of our humanity. It is the engine of progress. It is what will ultimately guide us to the answers we seek. 3I Atlas is currently traversing space at a velocity exceeding 90,000 kilometers per hour, carrying its secrets with it. In 5 weeks, it will achieve its closest proximity to Earth. What knowledge will we acquire? What discoveries will we make? Which questions will be answered? And what new questions will arise? I do not know. No one knows. And that, precisely, is what makes this so exhilarating. Maintain your curiosity, your healthy skepticism, and your openness to possibilities, and whatever unfolds, whatever Three-Eye Atlas ultimately proves to be, remember that we are living through an extraordinary era, an era in which the universe is unveiling its mysteries to us with unprecedented rapidity, an era in which the seemingly impossible is becoming achievable, and perhaps, just perhaps, an era in which we are on the cusp of discovering that we are not as solitary as we once believed. The narrative of Three-Eye Atlas is far from concluded. In many respects, it is only just beginning.